So this is the 6th video in my fastbook-benchmark video series, and in this video I'm going to implement ColBERT Search, which is late interaction retrieval. I'm going to implement the Plaid ColBERTv2 and the AnswerAI ColBERT small v1 models in the retrieval pipeline, and I'm going to use RAGatouille, which is also an AnswerAI library for this notebook. So a couple of things to get started. We have our pip installs and our imports. Everything is pretty much the same as before. A reminder, if you're running these notebooks, download my utils.py and load it up so that you can import all of the helper functions that I've created in previous notebooks. So I am going to download my data. That looks good. And then I'm going to load my benchmark. I'm going to chunk my data into a couple strings per chapter, and then I'll be processing that later. And then I'm going to group my questions by chapter. Cool. So that's all done. Now I'm going to use a chunk size of 500. And for now, I'm going to use chapter 1 for retrieval. So with that decided, I'm going to process my documents, and this will chunk them into 500-ish token strings. And I'm going to pass it my chapters data, and I'm going to pass it the chunk size. And if you've seen the other videos, you know that the length of documents for chapter 1 is going to be 57. Okay, good. So far so good. Now comes the actual retrieval part or setup for ColBERT. So I'm going to use my model name, which is ColBERTv2, and then I'm going to create the RAG object, and this comes from RAG pre-trained model, from pre-trained, and model name, and this is part of the RAGatouille library, which makes it really convenient to access these models for retrieval. Okay, cool. So I'm choosing to do index-free retrieval, so I'm not going to prepare an index. Instead, I'm just going to encode the full vectors for my documents and then use that for search. And I followed the RAGatouille example, so if you want to see how that works, you can check out their documentation. So I'm going to encode my documents, and I'm going to have some metadata, which I don't actually use, but I just did it for completeness. And just a reminder of the chapters that I'm using. So I'm going to set that, and that metadata is going to be set for all of the documents. So this should be relatively quick. It's encoding all 57 documents, and boom, it's done, and it's ready to go. Okay, so that is preparing the documents, token level embeddings or encodings for search. I'm going to set my top K to be 10. And now I'm going to just run through the loop for each question and run search using RAG. So I have my results as an empty list for now. And I'm going to iterate through my questions dictionary. So I'm going to go through each of chapter 1's questions. I'm going to get back the query results from search encoded docs, where the query is going to be, and let me capture the right syntax for this, which is here. So I'm going to strip double quotes from my string, and I want to pick the top K. One thing I actually want to do is that instead of hard coding 10, I'm going to take the minimum of the length of documents and 10. So it doesn't matter in this case because we know it's 57, but later on when I iterate through chapters, especially when we have larger chunk sizes, I want to use this implementation of top K. Okay, so I have top K here, and then RAGatouille retrieval or search results returns a document where it has the document ID, it has the content, it has the score, and so on and so forth. So I just want to grab the content for R in res, and then I'm going to append my results, and I'm going to make sure that the number of items in my results is equal to 30, one for each question. So I'll run this, and we'll take a look at there. So one thing that I'll do just for showing an example is, let's take a look at one of these results. And we can see here, so it's a dictionary, and there's content, there's the actual score, so this is the maxim score, the relevant score for each document. There's the rank, result index, and document metadata, and here's what we assigned at the beginning, and then it does this for the other 9 passages. So yeah, I just wanted to show what that looks like, and then we can run this again. So yeah, that is what our output looks like. I have everything I need. Let's get rid of this output. I have everything I need to wrap this into a function. So let's build it up here first. So I have my results, and I'm going to now iterate through all of my chapters. And the chapter results I'm going to concatenate. So it's going to be one set of retrieved passages per question. I'm going to copy some of my code above here. So I'm going to instantiate my RAG object. Let's grab this. OK. And then I'm going to process my documents, which is this one here. And I'm going to encode those documents. And then I'm going to define my top K, which is this here. And then let's see, so I can use pretty much what I have here, except I'm not going to use this results. I'm going to iterate through each question for the chapter. I'm going to search that question, get the results, and then I'm going to append this to chapter results. And once it does that, I'm going to extend this list with my chapter results. Okay, so that will go through every chapter. That will go through every question. It'll get the top K passages, and it'll store that. And I want to add some assertions. I'm going to assert that the length of my results is 191, the number of questions I have in my data set. And I want to make sure that each of these questions has less than or equal to top K values, top K passages. So this is going to be less than or equal to top K. And now we can wrap this in a function. And I'm going to call this function index-free retrieval. I'm going to give it my notebooks dictionary, data, the questions, and I'm going to give it the model name, and let's just use ColBERT2 as the default. Top K is going to be 10 as a default, and chunk size is going to be 500 as a default. So I have chapter here, I have model name here, the data for that chapter is being chunked here, and then I'm using top K here. So I think I'm going to remove the top K definition here because I'm already doing it down here. And then everything here looks good. Chapter results, results extend, and then the last thing I have to do is return my results. So I'm going to run that. And let's actually run retrieval for our entire question set. So index-free retrieval, notebooks, data, questions, and then everything else is fine. I'm going to use that model for this. And we should now see ColBERT doing its thing. Here's chapter 1, and then subsequent chapters, it's encoding and running the search on it. Cool. So I'm going to remove that output. I'm going to use my score retrieval function. Score retrieval. Give it my benchmark. Give it my results. And that should work. And it does. And then, as I've linked here, I've already done manual validation on my ColBERT v2 results, and I found that for my benchmark, these are the values that I'm getting for MRRs and recalls. So hopefully this should be the same, and it is, so that's great. And the cool thing is now I can just grab this code and grab this code. And then the only thing I'll change here is that I'm going to set the model name to Answer.ai's AnswerAI ColBERT small v1. And this should run very similarly. It has to download the model first. Okay, so that took 20 seconds. And then these are the values for AnswerAI ColBERT small v1. And you can see the MRRs in this case are a bit larger and the recalls are a bit smaller. And we run that, and that is correct. Okay, so that's a recap for how I've implemented late interaction retrieval using RAGatouille for the ColBERT models, and I've just used 2 of these models. Obviously there's other ones you could plug in as well. And so I think for now this will be my last video in the fastbook-benchmark series, but expect a lot more ColBERT retrieval content to be published in the coming weeks. And thank you for watching, and I'll see you in the next video.